Well, I'm back with one more video as I forgot that you guys had wanted, some of you had asked me for a video on density to go over density problems. So let's go over some density problems. So first question, what is the density of a piece of wood that has a mass of 25 grams and a volume of 29.4 centimeters, and that is centimeters cubed? Remember, it can't write power on here, so it's without the, it's without the power sign, so we'll have to accommodate for that. So the formula for density is density equals mass over volume. Okay, this is always going to be the formula for density. It's never going to change, just like the formula for speed is distance over time. Okay, and like speed, if you remember, if you had a teacher in middle school that taught you speed, distance, and time, that you had a triangle for it, and there was a triangle that helped you to figure out which equation to use when you were solving for speed, distance, or time. So there's a triangle that goes like this. And on the top of this triangle is M for mass, and on the bottom is density and volume. It doesn't matter where you put density and where you put volume, because they're both on the bottom and they're next to each other, so they're interchangeable. So if you're looking for the density, put your hand over the D, and you're going to see it's M over V. If you're solving for volume, put your hand over the volume, and now you see you have mass over density. And if you're looking for mass, place your hand over the mass, and now you see it's D times V. They're next to each other, and you know that if they're next to each other, that means multiply. So if you put your hand over the particular letter, it gives you the formula for the other properties. So right now we're looking for density. It says, what is the density of a piece of wood that has a mass of 25 grams and a volume of 29.4 centimeters cubed? Okay, so mass goes on top, and right here's our mass, 25 grams. So we're going to put that on top. Make sure to have your units, 25G, and the volume of it is 29.4 centimeters cubed. So we want to put that in the bottom for volume. Now, if you look at the units, you have grams on top and centimeters cubed on the bottom. You cannot cancel these out. Grams is your unit for mass, and centimeters cubed is your unit for volume, and they are measuring two different things. Mass and volume are not the same. I can have the same body size of another person. We can have exactly the same volume of body on the outside, but on the inside, I may have more atoms that are heavier, or they have more atoms that are lighter, and our density will be different because we do not have the same mass. We have the same volume on the outside, but inside we do not have the same mass. Okay, so the next thing we want to do is I always like to just write my units. So as I said, none of these units can be canceled out, so we need both. It needs to be grams over centimeters cubed. Okay, then the next thing I want to put this in my calculator, 25 divided by 29.4 is 0.850340136. So I'm going to write this down below so you can see it, but I want to do it with significant figures. 8.034, and that's all I need to write is that much. So if you look at your significant figures, this one on the top only has 2. This one on the bottom has 3. So remember, in multiplication and division, we go with whoever has less, and 2 is less, so we need 2 significant figures. Now 0 is not a significant figure, it doesn't count, so our first significant figure would be 8, and our second would be 5. We look at the number behind it says 0, so we're just going to drop those numbers in the back. So our answer is 0.85 grams per centimeters cubed is the density of this wooden block. So right here, this is my final answer. The density of it is 0.85 grams per centimeters cubed. Okay. So that's all you need to solve on that one. So let's go next slide. Let me copy another problem. Oops. Okay, a piece of wood that measures 3 centimeters by 6 centimeters by 4 centimeters has a mass of 80 grams. What is the density of the wood? Would the piece of wood float in water? Okay, well first I want to write I am looking for density because it's asking me for density, so I'm solving for density. So density equals mass over volume. And I see the mass of the wood, it's right here, 80 grams, so that's the mass of my piece of wood. But the problem is I do not see a volume. Oops, and I put 80 grams when it's really 80.0 grams. So make sure you write it correctly, unlike Ms. Cotta just did. So it's 80.0 grams. So that means that has 3 significant figures. Okay, so we need to multiply 3 centimeters by 6 centimeters by 4 centimeters because those are my sides. So one side is 3 centimeters, one is 6, and one is 4. So I need to multiply those 3 together to come up with my volume of the wood. So 3 times 6 is 18, times 4 is 72. So that's 72 even centimeters cubed. And what that tells me is that 72, that has 2 significant digits. And that's going to be important. So now I want to divide my 80 by 72. Okay, and I have grams over centimeters cubed, so I want to keep those units. Don't lose your units. And my answer is 1.1111 infinity. So I'm just going to make 3 ones and then put the infinity sign on top. But that is not my final answer because I need to worry about my significant digits. So this one had 3 and this one had 2. So whichever one has less, that's what my answer also needs to reflect. So I just need 2 significant digits. So here's my first significant digit, my second. I look behind it and it's only a 1. So all of this is going to get dropped. So my final answer is 1.1 grams per centimeters cubed. So that's the final density of this piece of wood. And that 3 was kind of ugly, I apologize. Let me make it bigger, decimal. Okay, so there's my final answer, but I haven't finished the whole question. Because the second part of the question, and make sure you're answering both parts of the question. Some of you guys are only answering the first part and not looking at the second part. So I answered, what is the density of the wood? 1.1 grams per centimeter cubed, even though this is not pretty cubed. So it looks a little better. Would the piece of wood float in water? Well, I know the density of this wood is 1.1 grams per centimeters cubed. And I also know the density of water is just 1 gram per centimeter cubed. And this density right here is more dense than water. So if this substance is more dense than water, this piece of wood is going to sink. And there are types of wood that sink. Not all wood floats. There are pieces of wood that sink. So it depends on the type of wood and how dense that piece of wood is. It's all about how closely together those atoms are. The more closely together they are, the more dense it is. So this piece of wood is sink, and we also have its density. So your 2 answers is the 1.1 grams per centimeters cubed, and then that it would sink in water is the second part. And this time it didn't say to explain it, but if it says to explain it, then make sure you're explaining why that piece of wood sinks, that its density is more than water's density. So in water, if its density is more, it would sink to the bottom of the water. Let's try another one. A new slide. A cup of gold-colored metal beads was measured to have a mass of 425 grams. By water displacement, the volume of the beads was calculated to be 48 centimeters cubed. Given the following densities, identify the metal. Okay, so we have these metal beads. We know the mass is 425 grams, and then by water displacement, they said the volume of the beads is 48 centimeters cubed. So we have the grams and the volume. We need to calculate the density. Once we know the density, we can tell you if it's gold, if it's copper, if it's bronze, because those are the densities of those metals that is listed. So we have all the information we need to figure out what exactly is this gold-colored metal. Did I bring gold, or did I bring something cheaper and bring copper or bronze? So let's remind ourselves of the formula for density. Density equals mass over volume. And so when you're looking for mass in this question, mass is always measured in grams. Okay, so make sure that grams is on top. So there's my density, 425 grams. And when I'm looking at my significant digits, this one has 3 significant digits, 4, 2, and 5. So 3 significant digits right here. And then my volume is right here, 48 centimeters cubed. So when you're looking for volume, it's going to be in centimeters cubed, or it could be in milliliters if it's a liquid. Okay? And this one only has, I'm sorry, it's not 48 centimeters cubed, it's 48.0. I did the same thing. You guys need to check me on that. It's not 48 centimeters cubed, but 48.0 centimeters cubed. Okay? Now, neither one of these units will cross out. And this one has 3 significant digits. I'm going to put myself little notes. So the grams and centimeters cubed won't cancel out, so I need to write those. Okay, now I'm going to do the division in my calculator. 425 grams divided by 48.0 centimeters cubed gives me 8.85416. And there's more digits, but that's all I need because I'm going to round it using my significant figures. Okay, so when I look at my significant figures, they both have 3 significant figures. So my answer also needs to have 3 significant figures. So I start counting 1 significant figure, 2, and 3. Remember, you always count from the front, not from the back. That one makes sense because your value starts in the front. Then I draw behind a line behind the third, and behind it is a 4, so that part just cancels out. Oops, not the grams doesn't cancel out, but the numbers back there cancel out. So my answer is 8.85 grams centimeters cubed is the density of this gold-colored metal. Okay, so that is part of my answer, so I'm going to box it. But what it's asking you to is, given the following densities, is this metal, what is this metal? Well, if I look at my chart, it's not gold, because gold is 19.3, and I only have 88.5. Copper is 88.6, I got 88.5. Sounds like I've got copper. I'm just off a little bit on my measurement. And then if I look at the next one, bronze is 9.87. Well, this isn't anywhere near bronze. It's a 1 gram per centimeter cubed less than bronze. So this must be copper. So the metal that I was calculating for is copper. It is not gold. It is not bronze, because the density of the copper matches with what I found in my data. Okay. One last question. And this one I'm going to draw for. Okay, so it's going to be kind of ugly, so bear with my drawings. Okay, so I'm going to draw a graduated cylinder. Wow, that one was really ugly, so let's try drawing that again. Okay, so there's a graduated cylinder, and here it is again. Okay, and what it was filled with water. Okay, so it's filled with water, and at the line of the water, okay, it was 25 milliliters. Okay, so this water in here was 25 milliliters. And then I dropped in this cube. Okay, so I dropped in a metal cube. Here's my metal cube. I dropped it in the water, and then my water went up. Okay, so my water level is higher than before, because think if you drop something into water, that water goes up, right? You put your little brother, sister in the bath, the water level goes up in the bath. So after this object was put in the water, now the water measures 32 milliliters. So what is the volume of this cube that I dropped inside this graduate cylinder? Well, take your old, if I can speak, take your new volume of 32 milliliters and subtract it from your original volume. So we had 32 milliliters of water after the rock was dropped in, but it is only 25 milliliters of water. So if I subtract what those two are, then that means just 7 milliliters is the volume of my cube. Okay, 7 milliliters. And I should have put more accuracy here, more precision. I should have put a 0.0 here and a 0.0 here, so that's my fault. And then this would be 7.0 as well. So let's say this is 7.0 milliliters. So it has a precision of 2 significant figures. We got 2 significant figures here. Okay. What I know about this ball, okay, this block, I know that this block has a mass of 13 grams. Okay, so that block has a mass of 13 grams, and we know its volume from what we just did in the first part. So now we can do density. So remember, density equals mass over volume, and density always is in grams. So the mass of that block is 13 grams. we did the calculation and showed that the that the volume is 7 milliliters. Now, neither one of these units cancels out. 13 grams does not cancel out, and 7 milliliters does not cancel out because they're measuring different units. And then here I have two significant figures. And then here with the 7.0 milliliters, I forgot to put the O again, sorry, 7.0 milliliters. It's also two significant figures. So both of them have two significant figures, so my answer needs to be in two significant figures. So when I divide this out, I've got 1.85714, and there's more digits, but I'm just going to take it that far because I don't need even that far. Don't forget your units, grams per milliliters. Okay. And now both of my numbers had two significant figures. 13 had 2 and 7.0 had 2. So I need to count two significant figures. So 1 and 2 significant figures, draw a line behind it. And when I look at the number behind it, it's a 5. So that is higher, 5 or higher. So we're going to take that 1.8 and turn it into a 1.9 grams per milliliter. So there's the density of that piece of block. He is 1.9 grams per milliliters. So if I was to put this block into water, it would sink because it's not less than 1 gram per milliliter, the density of water. So this is denser than water. It will sink if I place this block in water. Okay. So don't forget, you have review quizzes you can also do. Get ready for that test next week. Thank you guys.